Today we're going to be talking about the EGR system in a 1999 Acura TL and the PC system on a 27 Ram truck turbo. So here's the system operation of the EGR system that reduces oxides of nitrogen and emission by circulating exhaust gas through the EGR valve. We also have a valve position sensor that detects the amount of EGR valve lift and sends it to the PCM. The PCM then compares it with the ideal lift in its memory. Here's our sensor connected view for the valve position. Double check the color of the wires with your vehicle and make sure that each has the same voltage.
Okay, here's our wiring diagram for our EGR valve. We have the sensor here, and the yellow and blue wire is our ground. The white and black wire is our sense wire for the pintle position sensor. And then the green and black wire goes down to C. And at C, it just goes to the fuse box. Our EGR valve actuator is PCM driven and then just grounded. And it's just a 2-wire sensor with a pink wire and a black wire. And then as you can see on that C, that's where our green and black wire comes back, and it just goes into the fuse box underneath the dash. Here is our EGR valve right here. Unfortunately, all of the lines are cast into the block and intake manifold. They come from the exhaust down here and feed up into the intake manifold to the bottom, right up underneath there. I don't know if you can see that. But here is our connector. There's our black and white and our pink wire to control the solenoid, and then our other 3 wires for our signal. Okay, so our EGR valve is power side controlled by the PCM, and I did not want to tap that and put power into it. So now we have this mess. We're jumping wires for the Pintel's positions sensor with these top ones right here, and we're just sending those back to the connector so we get our 5-volt signal. And then down below we have our actual valve actuators, which are going to these power leads, and then we have it grounded, and then I have our power lead here that I'm just tapping to actuate the valve. And then I'm just sticking my multimeter lead in there on the black and white circuit so I can get the sensor from the potentiometer for that pintle. Okay, so now we're testing it with our actuator closed, key on, engine off. We're at 1.21 volts, and now we have that valve powered, and we're reading 3.68 volts on our pintle position switch. Okay, here we are ohm testing our pintle position sensor on the EGR valve. This is with it closed. We are at about 4 kilo ohms. And then now I'm going to open it by tapping on heel. And now we are at 1.64 kilo ohms with it open, and then back to 4 with it closed. And here's just a clip of how I'm actuating this. I have it powered, and I'm just... Here we are ohming the actual actuator of the EGR assembly, and we are sitting at 7.5 ohms. Okay, here we're going to force our EGR on by applying power to it remotely, and you can hear our RPM drop off. Hear that pop of it closing, and it revs back up, back down, closes, and it revs back up.
Here's our idle reading for the EGR as well as the ECT and the TP sensor. Here's our reading for a partially open throttle. Our TP sensor has gone down, our ECT temperature has gone up, and our EGR just stayed constant. However, it's not supposed to do this at all. Here's our scan tool reading for an unplugged EGR. Here's our AUT fuel trim map sensor. EGR. You can see the short spiked down. and the long field trim spiked up.
Here we have the EGR system on a 2007 Dodge Ram 2500 with the 6.7 liter. It is composed of an EGR cooler, a EGR valve, and airflow valve in the intake, and a crossover tube, as well as a temperature sensor. The EGR system is used to reduce NOx, and it mostly flows at idle and low load or low RPM situations. It uses the EGR airflow valve to limit airflow in the intake and back pressure in the exhaust to push the EGR gas through the actuator and into the intake. And here is a good diagram of airflow. As you can see, our EGR comes out of the exhaust manifold before the turbo, through the EGR cooler, which is filled with coolant and cools the gases, through the crossover tube and to the valve. And here is our airflow valve that creates the pressure differential necessary to allow EGR to flow into the engine and be recirculated. And here we have a 6.7 Cummins that no longer has the EGR, but we can talk about where things were. These are the blocker plates from where the exhaust would flow out of the manifold. There's one here and one back there, and it would go through the EGR cooler, and then it would cross over. Here is our temperature sensor for the EGR, and this is the tube that gives us our reading. The crossover tube would then come over here, and here is where the actuator would be mounted, and it would allow the exhaust to flow into the intake. And then down here is our airflow valve that limits airflow and allows EGR flow for the ability to run that, since at idle this truck builds a little bit over a pound of boost. Since there's no vacuum, it can't suck the EGR, it has to have a pressure differential.
In this vehicle, we found a vacuum-operated EGR. On this vehicle, we found a variable valve timing that are now replacing EGRs.
Today we are going to be working on the CCV system on this 2007 6.7 Dodge 2500. So the CDR closed crankcase ventilation system on this engine is composed of a filter, CDR valve, a pressure sensor, and drains. The filter pulls the atomized oil and puts it back into the crankcase via the drains. And the CDR valve and pressure sensor, the pressure sensor just is to alert the PCM of high crankcase pressure from blow-by, and the CDR valve senses pressure differentials between the intake tube and the crankcase and allows flow whenever the crankcase is at excessive pressures. Okay, here we have the CCV filter assembly housing. We pull this line. This is our breather that goes back to the intake. Pull this line off and pull this cover off, and we reveal our filter housing in here. And then up in the bottom there is our CDR valve, and it is a non-serviceable part. There are screws in it, but this whole piece is replaced as one. Here we have our filter assembly, and as you can see, it does not allow anything out of the top except out of this port, which has a check valve in it. And if we pull this out of here, you will see that there are drain ports on the bottom where oil can collect and drain back down into those, which this one is a drain that goes directly to the crankcase. And this over here is the pressure feed from the head. So any crankcase pressure comes through here, through the filter element, air goes back out and through this hose, and oil comes back down through here. Here we have our crankcase pressure sensor, and it is a 3-wire sensor down there, and it just reads like a map. The crankcase pressure sensor is also used to monitor the condition of the crankcase breather ventilation filter, and it can the ECM can also determine if the filter is even present based off of this sensor.